Hello. Today we will discuss about Introduction to Abstract Data Type with Baldorado Lian Mark, Bautista John Fonzy, Besin Elijah, Racelis Winston Hector, and Sayno Vincent Paul. So let's start. Abstract Data Types. Abstract Data Types or ADT is a type or class for objects whose behavior is defined by a set of value and a set of operations. The definition of ATT only mentions what operations are to be performed, but not how these operations will be implemented. It does not specify how data will be organized in memory and what algorithms will be used for implementing the operations. It is called abstract because it gives an implementation independent view. The process of providing only the essential and hiding the details is known as abstraction. And abstraction. Abstraction is one of the most powerful ideas in computer science, and it separates the what from the how. Abstractions provides modularity. Classes are the Python representation for abstract data types or ADT. Is a very useful notion in any programming language. In ADT involves both data and operations on the data.
The user of data type does not need to know how that data type is implemented. For example, we have been using primitive values like int, float, character data types only with the knowledge that this data type can operate and be performed on without any idea of how they are implemented. So a user only needs to know what a data type can do, but not how it will be implemented. Think of abstract data type as a black box which hides the inner structure and design of the data type. So here is the diagram which shows the relationships within the abstract data type. Application program is connected to interface which connects to public functions, which connects to private functions, and the data structure within is showed. Next. So here are the three types of abstract data types. First one is list abstract data type. Second one is stack abstract data type. And third one is queue abstract data type. Next.
List A type. The data is generally stored in case sequence in a list which has a head structure consisting of count, pointers, and address of compare function needed to compare the data in the list. The data node contains the pointer to a data structure and a self-referential pointer which points to the next node in the list. Next, a list contains elements of the same type arranged in sequential order and following operation can be performed on the list. We have get function which is return an element from the list at any given position. Insert function insert an element at any position of the list. Remove function remove the first occurrence of any element from a non-empty list. Remove at function remove the element at the specified location from a non-empty list. Replace function replace an element at any position by another element. Size function return the element of elements in the list. is empty function return true if the list is empty, otherwise return false. And lastly is full function return to true if the list is full, otherwise return false. We can see that this is how to work a list abstract data type. Next.
Stack stack abstract data type. In stack abstract data type implementation, instead of data being stored in each node, the pointer to data is stored. The program allocates memory for the data and address is passed to the stack ADT. The head node and the data nodes are encapsulated in the ADT. The calling function can only see the pointer to the stack. The stack head structure also contains a pointer to top and count of number of entries currently in stack. A stack is a LIFO, last in, first out. Next. A stack contains elements of the same type arranged in sequential order. All operations take place at a single end that is top of the stack and following operation can be performed. Push function insert an element at one end of the stack called top. Second, uh, pop function remove and return the element at the top of the stack if it is not empty. Next, pick function return the element at the top of the stack without removing it if the stack is not empty. Size function return the number of elements in the stack. Is empty function return true if the stack is empty, otherwise return false. Is full function return true if the stack is full, otherwise return false. Next.
So next is the QADT. The
Yon.
QA the Q abstract data type or ADT follows the basic design of the track abstract data type. Each node contains a void pointer to the data and the link pointer to the next element in the queue. The program's responsibility is to allocate memory for storing the data. Next slide. A queue contains elements of the same type arranged in sequential order. Operations take place at both ends. Insertion is done at the end and deletion is done at the front. So following operation can be performed. The first one is NQ. Insert an element at the end of the queue. DQ. Remove and return the first element of the queue if the queue is not empty. The third is pick. Return the element of the queue without removing it if the queue is not empty. Next is size. Return the number of elements in the queue. Is empty. Return true if the queue is empty, otherwise return false. Then the last one is full. Return true if the queue is full, otherwise return false. Next. So that's all and thank you.
So yun na po yung report namin about sa aming topic. Thank you for listening.